Australia may be sitting on one of the biggest untapped oil mysteries on Earth. Hidden beneath the red deserts and rugged ranges of Western Australia lies a sedimentary basin so vast it covers more than 530,000 square kilometres. That's larger than Victoria, larger than Spain, large enough that entire countries could fit inside its boundaries. Yet despite its immense size, despite decades of geological work, and despite the fact that oil has already been discovered there, nobody can confidently answer one simple question: how much oil is actually buried beneath the Canning Basin? What's even stranger is that this isn't some remote offshore frontier hidden beneath kilometres of ocean. The basin sits on shore, beneath the Australian outback, where drilling is possible and where geologists have already proven that oil-generating rocks exist. Oil has been found and has been produced. Yet compared to the world's great petroleum provinces, the basin remains remarkably underexplored. And that raises an extraordinary possibility. What if Australia is sitting on one of the largest unconventional oil accumulations on Earth and simply hasn't drilled enough holes to find out? The mystery begins in one of the most isolated regions of the continent. Stretching across northern Western Australia, from the Kimberley deep into the Great Sandy Desert, the Canning Basin occupies a vast expanse of seemingly empty country. To someone looking at a map, it appears remote and inhospitable. Distances are measured in hours of driving, infrastructure is sparse, roads often fade into dusty tracks stretching toward the horizon. Yet beneath this landscape lies an immense stack of sedimentary rocks recording hundreds of millions of years of Earth's history. These rocks tell a story of ancient seas, tropical reefs, shallow marine environments and deep ocean basins. Over immense spans of geological time, sediments accumulated layer upon layer, burying organic matter and creating the perfect conditions for hydrocarbons to form. For petroleum geologists, the ingredients are instantly recognizable. You need source rocks capable of generating oil, you need heat and pressure to transform organic matter into hydrocarbons, and you need pathways for those hydrocarbons to migrate. And ideally, you need reservoirs and traps where the oil can accumulate. The Canning Basin possesses all of these ingredients. In fact, one of the most important aspects of this story is that the petroleum system has already been proven. This isn't a theoretical resource. Oil has already been discovered and produced from fields such as Ungani and Blina. Wells have encountered hydrocarbons. Source rocks have been studied, reservoirs have been identified. The basin works. The real question is whether it works on a scale nobody has yet recognised. For decades, exploration focused primarily on conventional oil. Geologists searched for structures where migrating hydrocarbons might have accumulated into discrete fields. This approach led to discoveries, but none rivaled the giant oil provinces that transformed places like Texas, Saudi Arabia, or Bass Strait. As a result, the Canning Basin developed a reputation as an interesting petroleum province rather than a world-class one. Then the Shale Revolution changed everything. Before the early 2000s, formations such as Bakken in North Dakota and large portions of the Permian Basin in Texas were not considered among the world's great oil producers. Geologists knew hydrocarbons were present, but the rocks themselves were often regarded as too tight and too impermeable to produce economically. Then horizontal drilling and hydraulic fracturing transformed the industry. Suddenly, rocks once dismissed as marginal became some of the most productive oil provinces on Earth. Entire regions experienced drilling booms, production soared, previously overlooked formations became globally significant, and petroleum geologists began asking a simple question whenever they encountered organic-rich shale formations elsewhere in the world: could the same thing happen here? That question brought renewed attention to the Canning Basin. One formation in particular stood out. Known as the Goldwire Formation, this organic-rich shale extends across large parts of the basin and is regarded as one of Australia's most promising unconventional petroleum targets. Geological studies suggest it generated enormous quantities of hydrocarbons over geological time. In other words, the source rock did its job. The challenge is determining what happened next. Did most of the oil migrate away into conventional reservoirs? Did it leak from the system over millions of years? Or does a vast quantity remain trapped within the shale itself? Nobody knows. And that's where the numbers start becoming astonishing. According to assessments by the US Energy Information Administration, Australia's major shale basins collectively may contain around 403 billion barrels of oil in place, with approximately 17.5 billion barrels considered technically recoverable using modern drilling technologies. The Canning Basin is widely regarded as one of the major contributors to those national resource estimates. To appreciate the scale of those numbers, consider Australia's largest conventional oil field. The Kingfish field in Bass Strait has produced a little over 1 billion barrels of oil during its lifetime. It is regarded as Australia's greatest oil discovery. Now compare that to hundreds of billions of barrels potentially contained within Australia's shale systems. The difference is staggering, but there's a catch. Perhaps the most important distinction in petroleum geology is the difference between oil in place and recoverable oil. Oil in place refers to the total volume of hydrocarbons contained within the rocks. Recoverable oil refers to the fraction that can actually be extracted economically, and those numbers can be dramatically different. A rock formation may contain enormous volumes of hydrocarbons, yet only a small percentage can ultimately be produced. In unconventional shale systems, recovery factors are often surprisingly low. Yet even a low recovery rate can create enormous resources. Imagine a basin containing 100 billion barrels of oil in place. A recovery rate of just 5% would still yield 5 billion recoverable barrels. That would be one of the largest petroleum developments in Australian history. And that's precisely why the Canning Basin continues to attract attention. Some estimates over the years have suggested the basin's shale formations may contain tens of billions of barrels of oil in place. Other assessments have produced figures exceeding 100 billion barrels. The problem is that nobody has drilled enough wells to know where reality lies between those numbers. The Canning Basin has never experienced a drilling campaign involving thousands or tens of thousands of wells. Compared to Texas or North Dakota, the subsurface remains only lightly illuminated. Imagine evaluating a gold province larger than Victoria using only a tiny fraction of the drilling normally required. You might discover some deposits, you might identify a few mines, but would you confidently claim to understand a region's full potential? Probably not. That is essentially the situation geologists face in the Canning Basin today. The basin has not been ignored, it hasn't been forgotten, but many geologists would argue it has never been tested at the intensity required to properly evaluate its unconventional potential. Of course, there are reasons for that. The region is remote, infrastructure remains limited, drilling costs are high, water availability can be challenging, environmental approvals and cultural heritage considerations require careful management, and perhaps most importantly, exploration companies have finite budgets. Capital naturally flows towards projects with the clearest path to profitability. From a commercial perspective, uncertainty is expensive. From a geological perspective, uncertainty is irresistible. That tension has defined the Canning Basin for decades. Adding another layer to the mystery are the basin's ancient Devonian reef systems. Hundreds of millions of years ago, tropical reefs flourished across parts of the region. Today, those ancient reef complexes are among the most spectacular geological features in Australia. But buried reefs can do more than preserve fossils. Around the world, ancient carbonate reefs have become exceptional petroleum reservoirs. Their porous structures can provide ideal storage spaces for migrating hydrocarbons. Some of the world's most important oil fields owe their existence to ancient reef systems. Could similar reservoirs remain undiscovered beneath the Canning Basin? Again, nobody knows. And that uncertainty is what makes this story so compelling. In an era of satellites, advanced seismic imaging and supercomputers, one of Australia's largest sedimentary basins still refuses to reveal all of its secrets. We know oil exists there, we know the source rocks worked, we know conventional discoveries have already been made. We know the basin contains formations that resemble some of the unconventional plays that transformed North American oil production, yet we still cannot answer the question that matters most. How much recoverable oil is actually present? Maybe future drilling reveals the resource has been overstated. Maybe the basin ultimately proves to be a modest producer. Or maybe the opposite occurs. Maybe future exploration demonstrates that beneath the Australian outback lies one of the largest unconventional petroleum accumulations on Earth. Until enough drilling is done, nobody can know, and that is why the Canning Basin remains one of Australia's greatest geological mysteries. Beneath an area larger than entire countries lies a proven petroleum system capable of generating oil, yet compared to the world's major oil provinces, it remains only lightly tested by the drill bit. For geologists, that combination is irresistible. A giant basin, proven oil, ancient reef systems, organic rich source rocks, potential resources measured in the tens or even hundreds of billions of barrels, and a question that remains unanswered, not whether oil exists there, but whether Australia has barely begun to understand just how much. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.